You switch to Linux. You love the speed, the privacy, the fact that nothing is trying to sell you a Microsoft 365 subscription every time you open a text editor. And then you remember that one application. Maybe it's a specialized business tool your industry depends on. Maybe it's an older piece of software that does exactly what you need and has no Linux equivalent. Oh, maybe it's something your workplace requires. And the moment you remember it, the familiar compromise appears. Dual boot, or a virtual machine, or just giving up. But there is a third option that most people have never properly understood, and in 2026, it has become genuinely extraordinary. Let's start by clearing up the single biggest misconception about this tool, because that misconception is exactly what has caused millions of people to dismiss it before giving it a real chance. Wine is not an emulator. This is so fundamental to understanding what Wine actually does and why it can achieve what it achieves that the tool's developers embedded the correction directly into its name. Wine is not an emulator. The reason they did this is that emulator implies a simulation, a software reconstruction of Windows hardware and Windows kernel behavior running alongside the Linux system underneath it, consuming resources to pretend to be something it isn't. That is what a virtual machine does. That is not what Wine does. Cité indexpath 21-1. Wine implements Windows APIs in user space, so Windows executables can run without a Windows kernel. Think about that distinction carefully. A virtual machine creates an entire second computer inside your computer, running a full Windows kernel, consuming RAM that is permanently reserved for that virtual machine regardless of what you're doing, and requiring a valid Windows license to operate legally. Wine does none of these things. Instead, when a Windows application makes a request, asking the operating system to open a file, draw something on the screen, play a sound, send data over the network, Wine intercepts that request, translates it from the language Windows uses into the language Linux uses, and forwards it to the actual Linux system underneath. The application never knew it wasn't talking to Windows. Linux never had to pretend to be Windows. Cite index 22.1. Think of it as a really smart interpreter rather than a virtual machine. This distinction matters because it's why Wine can achieve near-native performance when it works well. Near-native performance, not theoretical performance, measured in benchmarks that don't reflect real-world use. Near-native performance in actual applications, because there's no overhead from running a second operating system kernel, no separate memory allocation for a virtual environment, no layer of hardware simulation consuming processor cycles. When Wine works well, a Windows application runs on your actual CPU, using your actual GPU, accessing your actual RAM, at essentially the speed it would achieve on Windows itself. And in 2026, the scope of when Wine works well has expanded to encompass an extraordinary range of applications that would have been impossible or unreliable even 3 years ago. To appreciate exactly how far Wine has come, you need to know where it started. Cite index-20E1. Wine was first released on July 4th, 1993 by Bob Amstadt and Eric Youngdale, 32 years ago. Wine has been in active development continuously for over 3 decades, maintained by an ever-growing community of contributors who have spent those 32 years building, piece by piece, a complete re-implementation of the Windows API in Linux-compatible code. Every Windows function that applications can call, every graphics primitive, every file system operation, every networking interface, every audio system call, every user interface element, all of it has to be translated and implemented in code that Linux can actually execute. This is one of the most ambitious software projects in the history of open source development, and its longevity tells you something important about both its complexity and its importance. The January 13th, 2026 release of Wine 11.0 represents the current stable release, and the scale of improvements in this single version illustrates how much the project has accelerated in recent years, driven substantially by contributions from Valve, whose commercial interests in making gaming work on Linux have provided a river of engineering resources flowing into Wine's underlying technology. Cite index 1930. 1. Coming in hot with absolutely masses of improvements throughout the whole project. From performance upgrades to massive technical changes, there's a little something for everyone. The Gaming on Linux community's reaction to the Wine 11 changelog was representative of the broader response. It's incredible how far things have come from the days when I was banging my head against the wall just trying to get Ultima Online to run correctly under Wine. Let's walk through what actually improved in Wine 11, because the specific changes tell a specific story about where Wine is heading and why the tool that once felt like a compromise has started feeling like something considerably more capable. Cite index 19.1. Highlights include better Wayland support, better pure 64-bit support to run 32-bit apps. It will use the NT-Sync kernel module when available for better accuracy and performance, improved ARM64 support, and so much more. The Wayland improvement matters more than it might initially appear to someone who doesn't follow the internal details of Linux display systems. Wayland is the modern display protocol that has been replacing the older X11 system as the default on most major Linux distributions, including Ubuntu, Fedora, and others that have been the primary home for Wine users. Previous Wine versions had genuine compatibility problems with Wayland, which meant users running the modern display stack on their Linux systems were sometimes forced into workarounds just to make Wine function correctly at all. Wine 11's improved. Wayland support removes that friction for the vast majority of users, making the default Wine experience on modern Linux systems substantially smoother out of the box. The NT-Sync kernel module is a more technically obscure but practically significant improvement. Cite index 21-1. NT-Sync represents a fairly unusual sort of addition to the Linux kernel, as it brings no benefit to native Linux programs. It just improves the performance of Windows binaries running via Wine. What NT-Sync addresses is the synchronization overhead that occurs when Windows applications use multiple threads communicating with each other. Windows has its own synchronization mechanisms that Wine previously had to simulate using Linux equivalents that don't quite match the performance characteristics of the Windows originals. NT-Sync adds Windows-style synchronization primitives directly to the Linux kernel, allowing Wine to use them when available, producing meaningfully better performance in multi-threaded Windows applications, which in 2026 means essentially every modern Windows program. The 32-bit application support improvement addresses a specific compatibility challenge that had been growing more acute as the Linux ecosystem moved fully to 64-bit architectures. Many legacy Windows applications, business software from the early 2000s, older industry-specific tools, specialized instruments with long replacement cycles are 32-bit programs. Getting these 32-bit Windows programs to run on a pure 64-bit Linux system required increasingly complicated library management. Wine 11's improved approach to running 32-bit apps on 64-bit systems simplifies this significantly, making legacy application compatibility considerably less headache-inducing than it had been. Cite index.18.1. The 2026 architecture leverages three critical enhancements. VKD3D Proton 3.10 Plus delivers full Direct3D 12 feature level $12.2 support, including mesh shaders, ray tracing acceleration on AMD RDNA 3 and NVIDIA RTX 40 series, and descriptor heap aliasing used by over 70% of games and GPU accelerated creative apps. Wine Mono 8.0 and Wine Gecko 3.1 provide integrated .NET 8, runtime, and modern web engine, enabling execution of Electron-based business apps and UPF applications previously stuck on .NET Framework 4.8. These are not incremental improvements to an already functional system. VKD 3D Proton's full DirectX 12, feature-level 12 Tabu 2 support means that Windows applications using the absolute most recent graphics programming interfaces, including ray tracing and mesh shaders, have a translation path to Linux's Vulkan Graphics API that preserves those advanced capabilities. Wine Mono 8.0's .NET. 8 runtime support means the entire category of modern Windows business applications built on Microsoft's current .NET framework, including many enterprise tools, productivity applications, and Electron-based desktop applications, now have a solid foundation for running under Wine. There's a piece of evidence about Wine's current maturity that carries more credibility than any benchmark or developer testimonial, because it comes from an institution that makes decisions based on rigorous security evaluation rather than enthusiasm or marketing. Cite index 18-1. In 2295, the German Federal Office for Information Security, BSI, officially endorsed Wine as a supported platform for running certified Windows-based cryptographic tooling on hardened Debian 13 systems. The German Federal Office for Information Security, known as BSI, is one of the most respected government information security agencies in Europe. Cryptographic tooling is one of the most sensitive categories of software they oversee. The fact that this institution conducted the evaluation necessary to officially endorse Wine as a supported platform for running certified cryptographic software on Linux is about as strong a credibility signal as any technology can receive. It means security experts performing formal certification evaluation concluded that Wine's implementation is reliable and controlled enough to run software in an environment where incorrect behavior could have serious security consequences. Now let's address the honest reality of what Wine can and cannot do in 2026, because intellectual credibility requires presenting the complete picture rather than the most optimistic possible version. Cite index chess22-1. The community discussion around Wine has shifted from will it run to how well will it run. That's a subtle but important change. But how well will it run implies that sometimes the answer is not perfectly, and that's accurate. Applications that require kernel mode drivers, low-level anti-cheat hooks, or deep Windows-only subsystem features remain outside Wine's reach. Kernel mode drivers, the software that hardware manufacturers write to make printers, specialized input devices, industrial equipment interfaces, and similar hardware work on Windows, require access to the Windows kernel itself, not just to Windows user space APIs. Since Wine operates entirely in user space without a Windows kernel present, these drivers simply have nowhere to load. The Wine project does not support the Microsoft Store, meaning applications that are exclusively available through Microsoft's distribution channel have no supported path through Wine. And kernel-level anti-cheat systems used by competitive multiplayer games remain the primary gaming limitation, as they also require kernel access that Wine cannot provide. But here's the thing about these remaining limitations. The category of applications that falls outside Wine's reach is considerably narrower in 2026 than it was even 3 years ago, and the category that now works reliably is considerably broader. Atom site indexed are 18:1. Wine is no longer a niche experiment. It's a mature, production-ready compatibility layer trusted by developers, designers, and enterprise users across the globe. Thousands of Windows applications, from Adobe, Lightroom Classic, and Microsoft Access to legacy industrial control software and niche accounting tools, now launch reliably without virtualization overhead or licensing costs. The practical assessment for any specific application is to check the WineHQ application database, which maintains user-submitted compatibility reports for thousands of Windows programs, and ProtonDB for gaming-specific compatibility information. These databases have grown substantially in recent years and provide specific, actionable information rather than general claims. Now here's where the story of Wine in 2026 becomes genuinely more interesting than the tool itself, because the way most people should actually use Wine has evolved considerably from the raw, command-line configured approach that gave the tool its reputation for complexity and inaccessibility. The problem with raw Wine, the version you install directly through your distribution's package manager and use for everything, is a specific architectural limitation that becomes apparent when you're managing more than one or two Windows applications. Cite index 30-1. If you just install Wine using your distro's package manager, that's the version of Wine that will be used for all your apps. And while some may perform better with newer versions of Wine, others might not. Having a single Wine install as the central point of failure for your Windows apps can cause problems. As Wine keeps evolving, in some cases, a newer version of Wine may actually be worse for running a specific app. Some things may stop working altogether, or new glitches may be introduced. That limitation points towards something that represents the most significant practical evolution in the Wine ecosystem in the past several years, a tool called Bottles. Cite index 27-1. Bottles is an open-source graphical application designed to simplify Wine management on Linux. Rather than maintaining a single Wine configuration that all applications share, a setup that frequently causes conflicts, Bottles allows you to create multiple isolated environments, each tailored specifically to a single application or category of software. The name is intentional and illustrative. Just as you might keep different wines in different bottles to prevent them from affecting each other, Bottles keeps each Windows application in its own isolated environment, with its own Wine version, its own Windows file system structure, its own library dependencies, and its own configuration settings. Cite index 30 wars 1. Instead of using a system-wide Wine installation, Bottles creates containers for each app you want to run. Each container can run its own version of Wine, with its own Windows file system and its own dependencies. Why does this matter so much in practice? Consider a scenario with two Windows applications. An older piece of business software that runs best on Wine 7.x because it was made before certain modern Wine improvements inadvertently broke some of its internal behaviors, and a newer application that benefits from Wine 11's improved .NET 8 support. With raw Wine, you choose one version and both applications live with it. With Bottles, each application runs in its own isolated environment with a specific Wine version that works best for it. When Wine updates and one application breaks, you update that application's bottle while leaving the other untouched. When you need to troubleshoot a problem, you address it in the specific application's isolated environment without risking any effect on the others. Cite index true 27-1. The combination of isolated Wine environments, automated dependency management, multi-runner support, and snapshot capability makes Bottles one of the most complete Windows application compatibility tools available to Linux users in 2026. The snapshot capability deserves specific mention, because it addresses one of the most frustrating aspects of the traditional wine experience, the fear of making a change that breaks something you can't easily undo. With bottles, you take a snapshot of an application's environment before making any change, whether that's installing an update, changing a configuration setting, or adding a new library. If the change breaks something, you restore the snapshot. The Windows application is exactly as it was before the change, instantly, without any manual reinstallation or reconfiguration. This single feature transforms the experience of managing Windows applications on Linux from something that feels permanently on the edge of irreversible breakage to something that feels genuinely manageable and safe to experiment with. Cite index Ausputat 27:1. The recommended installation method for bottles in 2026 is Flatpak, which provides access to the most up-to-date version and ensures consistent behavior across different Linux distributions. Flatpak, for those unfamiliar, is a universal Linux application packaging format that works across different distributions and provides sandboxing benefits. Installing bottles through Flatpak means the same installation commands work on Ubuntu, Fedora, Linux Mint, Arch, and essentially every other major distribution. And the installed version is always current regardless of which distribution's package repositories you happen to be using. The practical installation process with Flatpak requires 3 commands to get Flatpak itself ready if it isn't already. Add the FlatHub repository where Bottles is hosted, and then install Bottles itself. After that, launching Bottles opens a graphical interface where creating a new application environment, what Bottles calls a bottle, is a matter of clicking a button, choosing a name, and selecting which template to start with. Templates provide pre-configured starting environments for different use cases. A gaming template configures the environment with DXVK and other gaming-specific components. A software template configures it for general Windows application compatibility. And a custom template lets you start from scratch with full control over every option. Cite index 28:1. Instead of manually changing wine configurations, users can install ready-made environments for different uses like gaming, software development, and productivity applications. This accessibility represents a fundamental shift from the wine experience of even 5 years ago, when setting up wine for a complex application required reading extensive forum documentation, manually installing specific Windows libraries through a tool called Wine Tricks, and troubleshooting configuration problems that required understanding internal wine mechanics. Bottles handles the complexity automatically, making decisions based on community-established best practices and hiding the technical details behind an interface that any Linux user can navigate without wine expertise. Let's talk about the gaming dimension of this ecosystem, because it deserves its own honest, comprehensive treatment rather than simply being mentioned as an afterthought to the productivity application story. Proton is Valve's wine-based compatibility layer, specifically designed for games on Steam, and it represents both the most commercially significant deployment of wine technology and the primary source of the engineering. Improvements that have made wine's 2026 capabilities possible. Cite index 30:1. Wine is the foundation that makes gaming on Linux possible. Thanks to contributions by Valve through the Proton project, wine has evolved massively in recent years, and a lot of games are now playable on Linux this way. Cite index 21:1. Valve's SteamOS is noticeably driving both the performance and compatibility of Windows programs on Linux in recent years. Valve's investment in wine-based compatibility technology stems directly from the commercial success of the Steam Deck, their handheld gaming PC running SteamOS, a Linux-based operating system. Every game that runs better on the Steam Deck is a game that sells Steam Decks. Every improvement to Wine and Proton that makes more Windows games compatible with Linux is a direct commercial benefit to Valve's hardware business. This alignment between commercial incentive and open source development has produced an extraordinary acceleration of Wine's gaming capabilities, with VKD 3D Proton providing full DirectX 12 support, including ray tracing, DXVK providing high-performance DirectX 9, 10, and 11 translation via Vulkan, and NVIDIA FSR and AMD FSR both functioning correctly in the Wine Proton environment. The results of this investment are visible in the adoption numbers. Linux gaming share on Steam reached 5.33% in March 2026, a 52% year-over-year increase, and ProtonDB reports that over 80% of the top 1,000 Steam games run on Linux with a gold rating, or better, meaning they either run natively or work through Proton with no or minimal manual configuration. These numbers would have seemed fantastical to anyone who tried Linux gaming in 2018 or 2019. When the compatible game list was a small fraction of what Steam offered and performance was consistently worse than Windows for most titles. The ARM64 dimension of Wine's 2026 evolution deserves attention because it points toward where computing hardware is heading. and why Wine's ARM64 improvements matter beyond the current installed base of ARM Linux systems. Cite Index 21-1. On ARM64 Linux, Wine can use fexemu for x86 to ARM translation. A separate project called Hangover combines Wine and fexemu into one to let you install and run x86 Windows programs on ARM64 Linux. As ARM-based computing becomes increasingly prevalent both in consumer devices like the Apple Silicon Macs that many developers now use, and in the new generation of Qualcomm Snapdragon-powered Windows PCs and ARM Linux boards, the ability to run x86 Windows applications on ARM Linux systems becomes increasingly valuable. Hangover makes this possible by combining Wine's Windows API translation with fexemu's x86 instruction translation, effectively creating a two-layer compatibility system that allows an ARM64 Linux machine to run an x86 Windows application without requiring any of the components that application was actually built for. Let's address the practical question that most people watching this video are probably thinking right now. How do you actually know whether your specific Windows application will work through Wine or Bottles? And what should you do if it doesn't work out of the box? The WineHQ application database at appdb-winehq.org maintains compatibility ratings for thousands of Windows applications, submitted by users who have actually tested them. Applications receive ratings from Platinum, works perfectly with no manual configuration, through Gold, works with minor issues or requiring simple configuration, Silver, works but with some noticeable problems, Bronze, launches but significant functionality is missing or broken, to Garbage, does not work at all. Checking your specific application's WineHQ entry before investing significant time in setup tells you what to expect and often provides specific user-submitted installation notes that document exactly what steps are needed to get the application working correctly. For gaming specifically, ProtonDB at protondb.com provides equivalent information specifically for Steam games, with a similarly tiered rating system and user-submitted reports describing exactly what configuration adjustments, if any, are needed to get a specific game running. The Proton compatibility layer that Steam uses is significantly more specialized and optimized for gaming than standard Wine, so a game's ProtonDB rating is typically more accurate than a WineHQ rating for game compatibility. When an application doesn't work perfectly out of the box, the most common category of fix involves WineTricks, a helper script that automates the installation of Windows components, runtime libraries, configuration settings that specific applications require. Bottles includes WineTricks integration directly in its graphical interface, making it accessible without requiring command line knowledge. Common Windows components that applications frequently need include specific versions of the Visual C++ redistributable, the .NET framework for older applications that predate the modern .NET runtime, DirectX components for games, and various Windows fonts and system libraries. Installing these through Bottle's WineTricks integration is a matter of checking boxes in a list, and the installation handles the downloading and configuration automatically. Here's an honest assessment of what the experience of using Wine through Bottles actually feels like for different categories of applications in 2026, based on reported user experiences. For everyday productivity applications, things like Microsoft Office alternatives designed for Windows, legacy business tools, industry-specific utilities, and specialized software with no Linux port, the experience is typically functional and often indistinguishable from running the application on Windows. The German BSI's endorsement of Wine for certified cryptographic tooling is evidence of just how far the reliability has come for this category of use. For gaming, the experience is excellent for single-player and most cooperative games, with the remaining barrier being specifically competitive multiplayer games that use kernel-level anti-cheat systems as a deliberate policy choice by the game developers, rather than a fundamental technical limitation. Cite Index 22-1. People aren't just excited about compatibility anymore, they're excited about performance. And from what I've seen, that excitement is justified. For legacy industrial and specialized software, the situation varies considerably by application, but the WineHQ database provides specific guidance for many such applications. And the Bottles snapshot system makes experimentation low risk enough that it's genuinely worth attempting before concluding that a virtual machine is the only option. The question of how Wine compares to the virtual machine alternative that most people reach for when they need Windows software on Linux deserves direct, honest comparison. A virtual machine running Windows provides maximum compatibility because it runs a complete Windows kernel and full Windows environment. Any application that runs on Windows will run in a Windows virtual machine. This is the compatibility ceiling. The cost is performance overhead from virtualizing hardware, the RAM permanently allocated to the virtual machine whether you're using it or not, the storage space required for the Windows installation, and the Windows license required for legal operation. For a high-specification desktop machine with 32 or 64 gigabytes of RAM, these costs may be acceptable. For a laptop with 8 or 16 gigabytes of RAM that is also trying to run its own applications, permanently allocating 4 or 8 gigabytes to a Windows virtual machine that you may only need occasionally is a significant sacrifice. Wine through bottles occupies a different position. Lower theoretical compatibility ceiling, but near native performance, no Windows license required, no permanent resource allocation, and in 2026, a practical compatibility rate that covers the vast majority of what most people actually need Windows applications for. The combination of these factors makes wine through bottles the right starting point for almost any situation where you need Windows software on Linux, with the virtual machine as the fallback specifically for the applications that Wine cannot handle. The trajectory of Wine's development, from a project that famously required enormous patience and technical expertise in the early 2000s, to a production-endorsed compatibility layer with government security certification in 2026, is one of the more quietly remarkable stories in the history of open-source software. It was built incrementally, over 32 years, by contributors who were solving specific practical problems one at a time, with Valve's commercial investment accelerating the pace dramatically in recent years. The result is a tool that, for the specific problem it addresses, running Windows software on Linux without a virtual machine, has become genuinely excellent in ways that most people who formed their opinion of it years ago simply don't know. If you have been staying on Windows because of one specific application you can't replace, or if you switched to Linux and you're managing your Windows software dependency with a virtual machine that consumes resources and requires a license you'd rather not pay for, Wine 11 and Bottles in 2026 are worth giving a serious look. Check the WineHQ database for your application. Install Bottles through Flatpak. Create an isolated environment, enable the snapshot feature, and try. Site index 31. Bottles is really how you should be running Windows apps on Linux. It's more reliable, cleaner, and it can properly support more apps. The community discussion has definitively shifted from will it run to how well will it run? And for a genuinely impressive range of applications in 2026, the honest answer to that question is very well indeed.